Hong Kong 2022 Part 2. I released solutions of problem number 1 to 5. You can use the card on top of my video, the playlist. Now we want to solve this part. Problem number 6 is this. Subscribe my YouTube channel now and turn on notification please, and like the video to have next videos, and I will release the next parts. In this video we want to solve problem number 6 to 10. If you had any question about the solution of this problem or other problems, feel free to send message to my WhatsApp number in the description and comments. Problem number 6. Let PQR be distinct digits. A positive integer n is equal to 1 PQR in base 8 and RPQ. So let me use this. N equals 1 PQR in base 8 and RPQ in base 11. Find the value of n in base 10. Bases, for example, especially base 2, they have around, I can say, 8 important ideas. We will work on them in my classes. For example, here, when you multiply by 8 in base 10, you have 0. When you divide by 8, the floor is what? But here, I only tell you the thing that you need for this problem. So I should know how to change from base 8 to 10. So you should know this. Also 10 to 8. But here we need to know how to change from base 8 to 10, 11 to 10. I will explain here. Because it is in base 10, the value here is 1. In base 10 it is 10. In base 8 it is 8. Here it is 8 squared. Here it is 8 cubed. Here in base 11 it is 1, and it is 11, and it is 11 squared. The next thing you should know is that the digits in each base is less than, for example, in base 8, less than or equal 7. Here, less than or equal 10, 11 minus 1. So, because it is smaller, we can say PQR or less than or equal 7. And we can say there are distinct numbers, the problem says here. Okay, so let's calculate the first one. R plus 8Q plus 8 squared is 64P. 8 cubed is 2 to the power of 9 is 512. Here Q plus 11P plus 1 to 1, 11 squared is R. Okay, here, now we want to simplify. 8Q, we have 7Q here. R, and this, let's at first fill left side. 64P, 11P. If you subtract, it will be 53P plus 512 equals 1 to 1 minus 1, which equals 120R. Now, for solving these types of problem in also previous years of Hong Kong and other Olympiads, we work on the ideas with my students in my classes. For solving these types of equation, one important thing is to use congruency. Also in Hong Kong 2021, one problem, it has G, for example, 1664. It says we cancel that problem. In that problem, the hard parts we've solved with congruency. So here, if I want to use congruency, I consider some mods. For example, if I consider mod 3 at first, I can say it is what? It is Q. 53 is 8 is plus 2P. And the next one, 512, 5 to 7, 8, it will be plus 2, and this one will be 0. So here, if you take to the right hand side, 2 is negative Q, negative 2P minus Q. Negative 2 is 1 mod 3 is P minus Q. So the first thing, we can say P minus Q mod 3 is 2. Now, let's consider mod 4. 7Q is negative Q. 53 is plus 1 plus P is 0, 0, 0. So again, you can say P minus Q mod 4 is 0. The next mod we consider mod 5. Here it is 2Q plus 3P plus 2 is congruent to 0, you can say, okay, 2q is, if I want to change it to negative 2q, you can say this is negative 2p and take it to right hand side. Okay, so 2 negative 2p, negative 3p, negative 2q, negative 3 is 2. It will be 2p mod 5 minus 2q. So because it is mod 5. So because 2 and 3, 2 and 5 are co-prime numbers, you can divide both sides by 2. So p minus q mod 5 is 1. Okay, this is one important thing. You can divide under what condition? Look, congruency is like equality. You can multiply, add, subtract, but for dividing, you should pay attention that 5 changed to 5 over GCD of 5 and 2. If you don't know the properties of congruencies, because it is important from qualifying level up to IEMO, feel free to send message to my WhatsApp number in the description comments. Now, we have 3 mods. P minus Q mod 3, P minus Q mod 4, P minus Q. Let me write all of them in one part. P minus Q is 2 mod 3. P minus Q is 0 mod 4. P minus Q is 1 mod 5. And we know it has answer, and the proof that it has answer is Chinese remainder theorem. But here we don't need to prove, we need to find P minus Q is what? Mod LCM of 3, 4, 5, which is product of them because they're relatively co-prime each pair. So it will be 3, 4, 12 mod 60. We can find it mod 60. How we can find it? Has two ways, two important ways. In some problem, one of them works. In other problem, the other works. I will tell you one of them if you want to know the next one that is important for large numbers. As I said, feel free to send message to my WhatsApp number here. I say, okay, it is 0. I add it by 4, 4, and I want to see which one satisfy here. 4 mod 3 is 1. 4 plus 4, 8. 8 mod 3 is 2. So we can say P minus Q is 8 mod 12. It satisfies both of them. Now, here and here, I say, okay, it can say 8, 20 plus 12. I want to find something that mod 5 is 1. 32 is not good, plus 12, 44 is not good, 56. So here we've understood that P is satisfied. P minus Q is 56 mod 5. But we know what? P and Q are what digits? Are between 0 and 7. So P minus Q cannot be 56 or greater than that. Sorry, mod 60. LCM of 5 and 12. It cannot be 56, but 56 minus 60, negative 4. The only possible, and minus 60 again, it will be negative 64. The only possible case is P minus Q equals negative 4. So we can say what? We can say, okay, P plus 4 is Q. Now, one important idea we've solved in previous problems of also 2022 is replacement. Replacement is one of the most important things. So here we had this equation. We want to replace Q with P plus 4, and then we want to see then what we will have. 7, if you replace Q with P plus 4, it will be 7P plus 28 plus 53P plus 5, 12 equals 120, or 7P plus 53P, it will be 60P plus 28 plus 512 equals 120R. Here all terms are multiple of 4, so it will be 15P plus 7 plus 1, 2, it's 2 to the 9, 2 to the 7, over 4, it's 30R. Okay, 7 plus 1 to 8 is what? Is 135. And we can divide both sides by 5. It will be 3P plus 2 times 5, 35, 7 equals 6R. Now, I want to see, let me write this equation here, plus 27 equals 6R. We know P, Q, and R, all of them are between 0 and 7, so we want to see which one works. Here also we can divide by 3. It will be P plus 9 equals 2R. And P will be what? Let's check the cases. R is at most 7. Okay, because P is at least 0 and it is even, R is at least 5, because if it is 4, it is 8 and it is greater than 8. 5, 6, and 7, the only possible cases. For 5, it is 10, P will be 1. For 6, it will be 12, and it will be 3. For 7, it will be 14, and here it will be 5. Okay, now we had an equation between P and Q that we've replaced that. It was what? P plus 4 is Q. So we know P plus 4 is Q. So if I consider Q, Q is P plus 4. So here it will be 5, here it will be 7, here 4 plus 5, 9. We know PQR are between 0 and 7. It is contradiction. 7, 3, 6, 5, 1, 5. The assumption of problem is they are distinct numbers. So we have 5, 5, same numbers, contradiction. So the only possible case is 7 for these P and R. The problem says what? The problem says N is what? Let's check the problem in base 10. This one. N in base 10 is what? So let's copy one of them. Here we know N is this in base 10. And now we want to replace. Okay. R is what? R is 5 plus 8Q here. 8 times 7, 56 plus 64P. 64P, 64 times 3. 3 times 4, 12. 3 times 6, 18, 19. 5, 1, 2. Oh, sorry, here R is 6. We consider this case. Let me draw a line around that. Okay, it is 6. So if we calculate, it will be what? 6 plus 56, 62. 2 plus 2, 4. 9, 10, 6, 7. It will be 6 and 6 and 7. If you had any question about the solution of this problem, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem number 7. A spatial calculator contains a red button which counts the number of even digits of an integer. For instance, when the screen shows 2022, pressing the red button gives 4, since all 4 digits, even 4 digits. All 4 digits of 2022 are even. Someone inputs a positive integer n into the calculator and keeps pressing the red button until 0 is displayed. This part is important for the solution. On the screen, if 0 is displayed after the red button has been pressed 4 times, find the smallest possible value of n. Okay, so look here. If I want to say 1 doesn't work, 1 will be what? 0, because it has 0 even digits. 0 has 1 even digit. Is 0, it is 1. 1, 2, 3, 4. But the problem says until 0 is displayed, keeps pressing. So if we consider this until, so here this will be finished, but it says 4 times. So if it didn't have until, you could say, okay, if I place 2 here, it will be 1, 0, 1, 0. After 4 times, I will reach 0, and the answer was 2. But because the problem says until, it keeps pressing until the red button, until 0 is displayed on the screen. So here it will be finished, and it was after 2 times, not 4 times. But so consider that we see 0 for the first time after pressing 4 times the red button. So 0. Here, this one. Because it is 0 here, here it is at least 1. Why? Because if it is 0, then it is not the first time that we see 0. So it is at least 1. Now here, because it is at least 1, so here it has at least 1 even digit. So the minimum number that has only 1 even digit is 2. And then you say, okay, it is at least 2. Any number at least 2. So we can say here we have at least 2 even digits. The smallest number that has even two even digits is 20, because 2 digits here it can be at least 2, here it can be at least 0. Now, this number is at least what? It has 20 even digits. So the smallest number that has 20 even digits, 20. This one is not 0. It is at least 2. All of them are at least 0. So it will be 2 times 10 to the power of 19. And if you place equals this number, 2 times 10 to the power of 19, then here it will be what? It will be 20, it will be 2, it will be 1. Problem number 8, find the largest real root of the equation 2x squared plus 6x plus 9 equals 7x root 2x plus 3. Okay, so for solving these types of problem, when you see some roots, also it was useful in previous years of Hong Kong, we've solved these types of problems before. Consider this square root is a. So a is what? Root 2x plus 3. In algebra, there are around, I can say, in equality equation. Consider, for example, it is ascending, descending differentiation, and changing variables, factorizing techniques. There are around, I can say, for equation, not equalities. There are around 10, 15 important ideas. If you want to know them, feel free to send a message to my WhatsApp number in the description and comments. Okay, so if you raise both on, and we know a is at least 0 because it's a square root, we want to use that in the rest of the solution. A squared is 2x plus 3, so we can say x is a squared minus 3 over 2. Now, I want to replace this x here. It will be 2a squared minus 3 over 2 squared plus 6x. It will be a squared minus 3 over 2 plus 9 equals 7x. 7a squared minus 3 over 2 times a. Now we want to simplify this equation. So here the denominator will be 4, 2 here, then we have 2 if we cancel. So if you multiply both sides by 2, then I have a squared minus 3 squared plus multiply by 2, it will be cancelled. 6a squared minus 3 times 2, it will be 18, and times 2 here, it will be 7a cubed minus 21a. Now, if we expand these terms, it will be a4 minus 6a squared plus 9 plus 6a squared minus 18 plus 18 equals 7a cubed minus 21a. So 18, negative 18 and 18 will be cancelled. 6a squared, negative 6a squared, it will be cancelled. a4, negative 7a cubed plus 21a plus 9 equals 0. Now, here, that's the reason I said factorizing is important. We want to factorize. So here, I say I consider a squared here, a squared here. Let me tell you some hint. For example, because you don't have a squared, 0, so you have, for example, some a, the coefficient product of them times the product here and here, this times this and this times this, they will be 0. You can consider, for example, it is 9, and you can find it is negative 3. Negative 3, you create 9. So negative 3a squared, negative 3a squared. So I want to cancel that. So I place, for example, if I place negative 6 and negative here, then I have 6a squared, and I want to take it is exactly equal this. Why? Because if you check a4, it's okay. For a cubed, negative 6a cubed, negative a cubed, it will be negative 7a cubed. For a squared, it will be negative 3, negative 3, negative 6, negative 1, negative 6, plus 6 will be 0. 21a, it will be negative a, negative 3, 3a, negative 3, negative 6, plus 18, 18 plus 3, 21. Negative 3 times negative 3, it will be 9. So it will be okay. Now, I want to solve these quadratic formulas. The first one, a is negative b, 1 plus minus 1 minus 4ac plus 12 over 2a. Now, if you remember, I told you a is square root, so a is at least 0. So here I only consider the positive sign, because if you consider negative sign, the whole part will be negative. So it will be a for this one equals 1 plus root 13. Sorry, over 2a here is over 2, because our a here coefficient is 1. 1 over 1 plus root 13 over 2. And for this one, a is what? 6 plus minus 36 minus 4ac, which is plus 12 over 2. And it will be 6 plus minus root 48 over 2. Root 48 is greater than 6, so you shouldn't select negative. Then it will be negative, the whole part. So a will be 3 plus 2. It's 48 plus 12. 48 over 4. Because if you take 2 inside square root, it will be 4. Now we should check which of them is greater. So here it is 1 over 2. Root 13 is less than 4. 4 plus 1, 5. 5 over 2 less than 5 over 2, 2.5. So because the problem says what? A is 2x plus 3. It says find the maximum root. So if a is greater than x is greater, both of them are ascending. And so we should consider this root that is greater for a and result largest root for x. So we can conclude 3 plus root 12 equals what? Root 2x plus 3. If we raise both sides to the power of 2, it will be 9 plus 12 plus 2 times 3, 6. 6 root 12 equals 2x plus 3. And if we simplify here, it will be what? 3. If you take it here, it will be 6. If you divide by 2, it will be 3. It will be 6. It will be 3. So x will be what? 3 plus 6, 9. And you can say root 12 is 2 root 3. So it will be 6 root 3. So the largest root of this problem is this. Okay, so if you had any question about the solution of this problem or other problems, as I said, feel free, or want to learn how to solve these types of problems, feel free to send message to my WhatsApp number in the description and comment. Okay, problem number 9, geometry problem. As I said before, for geometry, there are around 50 important formulas that if you learn them, you can solve problems from qualifying level up to IEMO. I told the formulas to my students, also some students in Hong Kong. So let's solve problem number 9. ABCD is a square with side length 1. P and Q are points, so let me draw it. ABCD is a square with side length 1. So it is 1, it is also 1. P and Q are points on AB and BC. P on AB and Q on BC. Such that, respectively, such that BP equals BQ. So it is 1 over root 2. And also BQ is same. N is the foot of perpendicular from B to CP. So let me draw it with green. From B to CP, something like this one. And okay. N is this. And then it says for what? Find NQ squared. Let me draw it with pink. NQ squared is what? So here it is what? 1 over root 2. Because the length of this side is 1. So it is 1 over 1 minus 1 over root 2. Now, for this problem, we want to use Stuart's theorem. As I said, there are around 50 important formulas you should know about geometry. Also, I told my students this theorem for any exam. So you can solve it. And here we have a formula for finding NQ by Stuart's theorem. You need to find BC, BQ, CQ, we have them, BN and CN. So we want to find them. So let me write the Stuart's theorem for this triangle. It will be what? It will be BC. Let me write from here. BC times NQ squared plus BQ CQ times BC equals what? BQ NC squared, BQ times NC squared plus CQ times BN squared. CQ times BN squared. So here the only thing we need to find BN and CN. Okay, here if I want to find BN in this triangle, I know the area is what? It is this times this over 2. If we find CP, then we can find this altitude. So finding CP, we can easily find it by Pythagorean theorem. So CP squared is what? Is 1 over 2 this squared plus 1 squared, which is 1. So it will be 3 over 2. So CP is what? Is root 3 root 2. Area of BPC is what? Is 1 over root 2 times 1 over 2, which will be 1 over 2 root 2. Now here we can say, okay, CP times BN over 2, it's the area, equals 1 over 2 root 2, the area. We replace CP with root 3 over root 2 times 2 times BN equals 1 over 2 root 2. We cancel, so we conclude BN equals 1 over root 3. So we found BN that we need. Now it's the time to find CN. Okay, if we want to find CN, here it is 1 CB. Again, if we use Pythagorean theorem, it will be what? Let me write here. I can say 1 squared. So let me write CN squared is what? 1 minus BN squared, which will be 1 minus 1 over 3, which equals 2 over 3. Okay, so let's here replace BC is 1, NQ squared, we want to find that. BQ is what? Is 1 over 2, 1 over root 2. CQ is what? 1 minus 1 over root 2. BC is what? BC is 1. BQ is what? 1 over root 2. NC squared is what? 2 over 3. CQ is what? Let's CQ. 1 minus 1 root 2. And BN squared is what? 1 over 3. So let's copy this and simplify and calculate. So Ctrl C. Okay, so here I can say what? NQ squared plus. Here you can say, if you use common denominator root 2, it will be 2. And it will be root 2 minus 1 equals what? This times this. It will be 2 over root 2 is root 2 over 3. Plus this one is what? 1 over 3 minus 1 over 3 root 2. So here we can say what? The problem says find NQ squared or NQ squared. Okay. So here you can say if you want to use denominator rationalize, it will be multiplied by root 2 and root 2. It will be root 2 over 6. So NQ squared is negative root 2 over 2 plus 1 over 2 and plus root 2 over 3 plus 1 over 3 minus root 2 over 6. Now, here it will be what? If we use common denominator 1 over 6, it will be negative 3 root 2 plus 6, it will be 3 plus 2 root 2 plus, here it will be 2 minus root 2. And let's see, it will be what? 1 over 6. 2 plus 3 is 5. 2 root 2 minus 2 root 2. It will be this. Problem number 10 in triangle ABCDEF are points on BCCAAB respectively, such that the line segments ADB and CF meet at G. Okay, so before reading the rest of the problem, for solving this problem, as I said, there are 50 important formulas. One of them is this. DG, you can prove it by areas DG over what? DA plus EG. So look, this one, this over this plus this EG over EB plus FG over FC. Sum of them equals 1. And how you can prove it? Okay, so let me copy this for, then we want to solve the problem. Now, I want to prove at first this. How? I can say by Thales theorem, or you can say similar triangles. I can say it is T prime. So DG over DA is what? Because they are parallel, you can say it is equal to GT over AT prime. GT over AT prime, you can say it is ratio of area of GBC over area of ABC. Why? Because the bases are same, the ratio of their area is ratio of their heights. So here, if you write this, it will be area of, let me show with pink, area of this over ABC. Similarly, you can say EG, this one over EB is area of this over ABC. And the last one, if I show it with, let me show it with red, it is area FG, area of this over ABC. So if you add all of them, the numerator will be sum of them, the denominator is same for all of them, area of ABC. So it will be, at the end, it will be area of ABC over area of ABC equals 1. We want to use this for our proof. The next thing the problem says, let me paste the figure again. So here it says if the lengths of DG, EG, BG, AG, and CF are 1, 2, 3, 4, 5. So DG is 1. Let me show DG is 1 here. And EG is 2. BG is 3. EG is 2. BG is 3. The next one, AGCF. AGCF 4 and 5. AGCF. Okay, so CF is 5. We don't know CG and FG is what, but with this idea we calculate what the problem says. Find the area of ABC. Okay, so let's solve. By our lemma here, we say 2 over what? 2 over 5 plus 1 over 5, this over this, 2 over 5 plus 1 over 5 plus FG over CF equals 1. Now we know CF is what? CF is 5. So if we multiply by 5, it will be 2 plus 1, 3 plus FG equals 5. So FG equals 2. So FG is 2, and since CF is 5, so it will be 3. Okay, so let's copy this one and maximize the figure. We want to find area of ABC. Okay, so let me 4, 2 here, are you right? 4, 2, 3, 1, 2, 3, 3, 1, 2, 3. Now I want to write the areas. So if we use the formula that for each triangle, for example, also this formula that for each triangle ABC, we have many things for area. You can say it is equal to what? 1/2 BC sine A. It is B, it is. Now if you use that here, this triangle and this triangle, these angles are equal. So you can say the ratio of the areas here 3, 1, 4, 2, 3 over 8. So you can say this area is 3x, this area is 8x. Also, if we use here, it is 3y, and it is what? 8y. And these two areas, it is 2, 3, 2, 3. So this area is W and this area is W. Okay, now here it is 4, 1. So if now you use this part, the altitude is same. So the ratio of the areas is 4/1. Ratio of the bases. So W plus 8x over 3y equals 4/1. So if we cross multiply, W plus 8x equals 12y. So we can replace W with 12y minus 8x. Another thing that we can say here is W here is 3y plus 3x. So we can say what? We can say W over 3x plus 3y is what? 2/3. So we can divide both sides, multiply both sides by 3. So then we have W equals 2x plus 2y. I want to write all things in terms of x. So here is 2x, 2y. Now here, if you replace W is what? 12y minus 8x. And it will be 2x plus 2y. If we divide both sides by 2, it will be this, 4, 6y minus y will be 5y, and negative 4x here it will be plus 4x plus x, 5x. So we proved that x equals y. So W is what? 12x minus 8x, 4x. Okay, now we can write all areas only in terms of x. So let me copy this one again and paste it here. So I erase this anything. 8y is 8x. And W is what? We said W is 4x here. 4x. 3x. And this one is 3x. So we found all the areas in terms of x. If we find x, then we can find the area of ABC. Here we can say, okay, triangle GBC is isosceles triangle 3, 3. And because the areas are equal 3x, 3x, so the ratio BD over DC is 1. So it is equal. So because it is isosceles triangle, it is altitude. So we can say, okay, for triangle ABC also AD is both altitude and median. So this is an isosceles triangle. So if I draw a better figure, it will be, okay, here. And this is our triangle 1, 4, 2, 3, 2, 3. So here, because it is 3, 1, if you use Pythagorean theorem, let me call this is G, and it is DEF. I can find DC is root 9 minus 1, it's root 8. Now, because we have 4 and 1, we can say what? We can find this one, but we don't need, because we want to find area, it is root 8. Also, it is root 8. So altitude is 5. 5 times 2 root 8 over 2, which will be 5 root 8. I think for this problem, we've used around 3 important formulas. If you want to know all 50 important formulas, around 50, as I said before, feel free to send message to my WhatsApp number in the description and comments. Then all these problems are not hard for you.